Okay, college algebra, pre-calc. We're going to pick up with, this is still 2.1, and we're going to kind of move into 2.2 a little bit. 2.1, 2.2 kind of go together. Sorry for not having much of a distinction there. I don't know for sure exactly what your notes and stuff, but you should know domain by now. So this is good practice for you. The square root of 9 minus x, you should say that you can only take the square root of positive. So 9 minus x must be greater than or equal to 0. And so when you subtract the 9, negative x is greater or equal to negative 9. And divide by negative 1, x is less than or equal to positive 9. So your domain would be from negative infinity to 9 with a bracket. Domain here simply can't divide by 0, so x cannot be 2. Domain here can't divide by 0. The bottom factor is x minus 3 times x plus 2. So therefore, x cannot be negative 2 or 3. A lot of times people start saying 2x plus 5 is greater than or equal to 0, but you can take the cube root of negatives. No big deal. So domain is all real numbers, negative infinity to infinity. Now we get to something a little bit more difficult. Square root of 9 minus x squared. You cannot take the square root of a negative number. So therefore, you need to consider 9 minus x squared is greater than or equal to 0. Now, whenever you have an inequality that involves an exponent like that, something that's nonlinear, you need to consider the graph. 9 minus x squared is a parabola that goes upside down. It crosses at negative 3 and at positive 3. Where is it greater than or equal to 0? Wherever it's above the x-axis. Well, it's above the x-axis right here. So therefore, the domain is negative 3 to positive 3. And for our last one, when you consider this expression, you know that you can't divide by 0. And 0 and 1 will give you 0 in the denominator. If you look at the numerator, you know that x must be greater than or equal to 0. When we sketch that graph, they're kind of in conflict with each other. Look at the top, greater than or equal to 0. So I plot the 0 there. But then we know that x can't be 0 and it can't be 1. So you actually have to open up the circles on those. So the domain becomes 0 to 1, union 1 to infinity. So you should be ready for really any domain problems. And if you're confused about that, please come and see me or reach out and let's do a Google Meet. Okay, as we start to talk a little bit more about graphs of functions, so now instead of looking at them analytically, you're going to be able to see them. Given the graph of the function f, identify the following. This notation, f of negative 2, means that if you plug in a value of negative 2, that's the x value. What's the corresponding y value? In that case, it would be 1. F of negative 1, notice how when you look at negative 1, there looks like there's 2 points. You have an open circle there and the closed circle up here. So we choose the closed circle. The open circle is not defined at that spot. And you have another value of 1. F of 0, again, you get a value of 1. Some people say it has to have a dot there. No, the line is there. That's enough. It doesn't have to have a dot per se. F of 1, we plug in 1. Notice that open circle, but defined down here. So we would say negative 2. And finally, f of 2, if you plug it in, you can see you get 1 there. The domain and range of f. The domain in this situation. The domain is whatever x values it covers. So I like to take that vertical line and drag it across and see what I get. So there's my vertical line. I'll now start dragging it across. See, I have values here. And even at negative 1, I have values. And at 0, I have values. And here I have values. And it looks like, even though the graph is a little bit broken, I have values all the way from negative. In this case, it looks like negative 4 to, 4.5. But we're going to say that there's arrows on there. We're going to go from negative infinity to positive infinity. Now, the range, I drag a horizontal line. And I'm going to take that horizontal line, move it on up like this. And you can see that all the way down negative infinity, the graph will cross. Still here, still here, still here. How about this open circle? Yep, actually crosses twice. Up here, yep, crosses. Yep. But then at 2, it lets out. So therefore the range, it starts at negative infinity and goes up to 2, but 2 with a parenthesis, okay? Not 2 with a bracket. Sorry about that. Let's look at this last question. The domain values that satisfy f of x equal to 0. So the question is, when does the function have an output of 0? And if I drag this line down here, well, why are you doing that? Oh, because the marker's in my pocket. There we go. If I drag this down, when does the graph cross 0? At what x values does that happen? You see it happens at x equals negative 3. Remember that there's an open circle here at negative 1, and that happens again at 4. Okay? All right. Use a vertical line test to determine if the following are functions. So I'm going to draw a few functions here. Draw that one. We'll draw this one. Draw this one. And we will draw this one. Okay, so if I draw those 4 graphs, the vertical line test says that if the graph crosses the vertical line, or I should say if the vertical line crosses the graph at more than one spot, then it ceases to be a function. It is not a function at that time. So you can simply just take this vertical line, drag it across. You can see everywhere I place it, it only crosses at one spot. So therefore, the first one is a function. The next one, as you drag it across, notice that it crosses multiple times in just about every spot. So this is not a function. In the next one, crosses once, and then it doesn't cross anywhere, and it crosses once. So this is a function. And then the last one, as you drag it across, you can see it just crosses once. But then when you get to this spot, a vertical line maps over a vertical line, and that would cross an infinite number of times. So therefore, this is not a function. Great. All right, this one says determine whether the equation defines y as a function of x. So when you look at it, can you tell whether or not it's going to be a function? And to show you how we do that, we simply just solve for y. And notice in this situation, if you subtract 2x squared, we get negative 4y is equal to 8 minus 2x squared. We divide by negative 4, and we have y is equal to 1/2 x squared minus 2. So as you solve for y, notice that if you plug something in for x, you get just one output. So therefore, yes, this is a function. Now, your mind is going right now saying, well, what about, what would it look like if it wasn't? Well, look at this next example. If I solve for y, I subtract x squared from both sides. I have y squared is equal to 9 minus x squared. And then as you square root both sides, notice you're square rooting a variable of y squared here. And so you must list both the positive and the negative root of 9 minus x squared. That means if you plug in, say, a value of 0, so we have an x value of 0, what comes out? Well, 9 minus 0 is 9, and the square root is 3, and it tells you list both positive 3 and negative 3. Well, this is not a function, because in this situation, the domain value of 0 corresponds to 2 x values. The domain value of 0 corresponds to positive 3 and a negative 3. And so therefore, it's not a function. So if you see a y squared, it's a very good chance that it's not a function, because when you square root it, as you can see, you get 2 options there. And maybe you knew right away because you had this on a test. X squared plus y squared is equal to 9. You should remember that that's a circle with a radius of 3. And you know that circles don't are not functions as well. They don't pass a vertical line test. So multiple ways that you can kind of see this through. Just know that those are things that you should remember over time. All right, the last one is solve for y. This one's got a cube, so you might say, well, it's not a function. Well, let's try it. Subtract x, subtract 3. So negative y cubed is equal to negative x minus 3. I divide by negative 1. Y cubed is equal to x plus 3. And then I cube root. When you cube root, you have y is equal to the cube root of x plus 3. Now, cube root, you can take the cube root of a positive, you can take the cube root of negative. It turns out in this situation, when you cube root this guy, you do get just one solution. So cube roots are not a problem. This is a function. Good morning. And now we get to our last section. A couple people in my room right now. This might be helpful for them to watch this if they want. It's up to them. This is where some people really get confused. And in this situation, we are graphing piecewise functions. This is graph the following piecewise functions. So you can know, as you see these functions sit in pieces. And there's multiple ways of doing this, and don't write what I'm going to write right now, okay? But the graph of 3, y is equal to 3, is a horizontal line that passes through 3. And the graph of y equals x minus 4 is a graph of a line with a slope of 1 that passes through negative 4. Okay, didn't draw that really well. Sorry about that. We'll try to. There we go. And you can see if I put both those graphs down, they are not functions together because they don't pass the vertical line test. In fact, what I have to do is I have to separate it at 2. It says that it wants to be the graph of 3 went up until you get to x is equal to 2. And it wants to be x minus 4 when you are after 2. So what that literally means is that graph of 3, I get rid of anything after the x value of 2. And that graph of x minus 4, I get rid of anything that happens before 2. And then by the look of it, you can tell that I'm going to have an open circle there and a closed circle here. Now, instead of erasing, how I tell people to generally graph these are to first get into your mind a visual understanding of what the graphs look like, which is, those two lines. After you have those two ideas in your mind, then go ahead and plug in this point right here, which is 2. And when you plug in 2, you get an output of 3. So what I do is I plot that 2, 3. It is an open circle. And I sketch the graph that remains to the left because it's for x values less than 2. And then I plug in 2 here and I get negative 2. So I plot 2, negative 2. As you can see, it's a closed circle. And I continue to draw a line with a slope of 1 after that. So that is the graph of that piecewise function. Let's try it again. Again, in my mind, you don't draw this, you don't write this down, but I think of x plus 3, and I think of x squared. Those are the two graphs that I want to be sketching, but I just want parts of them. What parts do I graph? We plug in negative 1, and we get 2. So I plot negative 1, positive 2, full circle, and I draw a graph with a slope of 1 off to the left side. Then I plug in negative 1, and I get 1. Open circle. You can see it drops down to 0, it comes back up. There is your graph. Uh-oh, craziness, we got 3 graphs. Big deal. 4 minus x squared, you know it's a parabola, it's upside down, shifted up 4 units. The graph of negative 2, you know, is a horizontal line through negative 2. And x minus 5 is a line that travels through negative 5 on the y-axis. Those are the 3 graphs that you keep in mind. Now that you have them in mind, let's go ahead and sketch the graphs. I plug in 1, and I get 4 minus 1, which is 3. So 1, 3, open circle. Remember that graph came up to 4 and dropped back down. Now I'm going to sketch -2. When I plug in 1, I get -2. When I plug in 3, I get -2. 1, -2, and 3, -2. There's my horizontal line that connects them together. And finally, we plug in 3. When you plug in 3, you get -2. I plot 3, -2, open circle, and I draw a slope of 1 after that. There's my sketch of my piecewise function. There you have it, folks. There's your kind of your 2.1, 2.2 lesson on graphs. Stop this, and got questions, reach out to me. I hope you have a great day, folks.